Alrighty, are we live? We back? Hello, hello. So, let me see if I can pop out this chat again. I'm gonna try. Oh, it's not working. Nope. Getting denied access to the chat. That's okay. So, alright, the next question is going to be as follows. Might as well go ahead and, so that one worked, that was fine. Walls and gates. Let's give that a shot. Yeah, the previous one was pretty interesting, but I kind of want to just keep rolling right along, keep moving right along. You were given an m by n grid, rooms initialized with these three possible values. You were given an m by n grid, rooms initialized with these three possible values. -1, a wall or an obstacle. 0, a gate. Infinity means an empty room. We use the value to the 31st minus 1 equals, that's like int max, represent infinity, as you may assume that the distance to a gate is less than that amount. Okay. Fill each room, empty room with a distance to its nearest gate. If it is impossible to reach a gate, it should be filled with infinity. Okay. This is an interesting question. No, that's a very interesting question. I actually don't know necessarily how to solve this. I think you can use a search algorithm. However, I'm not entirely sure what to do, where we want to go, what we want to do with this one. So. Okay. Just want to check to see if briefly check the chat. So, interesting. Oh, okay, so it starts off at infinity, it's empty to begin with. Alright. And we want to update. So, there's a few things to say about this. This may or may not be related to certain graph search algorithms. Just gotta think, what could this be? What is Dijkstra's algorithm, right? Because Dijkstra's algorithm is pretty useful for finding shortest paths. It's the shortest path between two nodes. That's no. It's actually. What does Dijkstra's do? It's related to that. Shortest path, first algorithm. Shortest paths between nodes in a graph. Shortest path between two given nodes. A node is the source and finds shortest paths from the source to all of the nodes. Shortest path tree. Yeah, okay. Yeah, it's a little different than. So it's basically between any two. You pick a node, and then you find the shortest path to all the other nodes from that node. It's a shortest path tree. It's shortest paths for each other node. There's a shortest path, and the Dijkstra gives you that shortest path. Got it. Gotcha. That's not the same thing as this question. This question is kind of special. This question is asking you want at every position the shortest distance to any particular gate. The gate is 0, and you can't cross through the walls or obstacles. And if you can't get to a gate, then you put in, you don't change the distance. You keep it at infinity. So pretty interesting question. I think for something like this, I mean, this kind of lends itself to dynamic programming, and particularly I like recursion. This is a question that seems recursion's a lot easier because this is sort of a depth first search question. Basically, you would say at each position for all of the other positions that now, here's one more question. Can you go in any direction? That's a question. Seems to lend itself to a depth first search algorithm. Yeah, I think it's really simple to do it that way. We'll do it that way. Yeah. Yeah, this should be pretty straightforward. We're gonna memorize it. Memorize the function. Yeah. Okay. Okay. Now, I'm wondering if I can rewrite this using a dynamic programming solution, though. Yeah, probably could. This gets kind of funky, you know? It gets a little funky. Because the problem with this is the dynamic programming approach. The problem you run into is that you want to know if you want to know these other values when you're evaluating this point. Like if you go from the top left to the bottom right, you kind of run into some problems. Yeah, that's a tricky thing about the dynamic programming solutions, where you kind of have the inductive hypothesis assumes previous knowledge, I guess, where other approaches, the inductive hypothesis assumes that you will have that knowledge, which is a little bit different. But anyway, so we have to be careful about. We want to use a depth first search, but we don't want to revisit any nodes. Oh, actually, we could use an unordered map for this. I forgot. There's a tricky thing we can do. Actually, not even an unordered map. We can do is just use a vector for our. We can outright use a vector for our algorithm for our memoization, which is pretty nice. We want to think about this for one more moment. Yeah, we're just going to use depth first search, curse on all 4 directions, memoize the results. The recursions are just going to say get the best. There's sort of a children's set, get the best result of those 4 directions. Excuse me. One tricky thing to remember, obviously building the children's set, we're going to do that using directions. We're going to try to do that sort of succinctly. One tricky thing is to make sure that we do not revisit we don't want to revisit nodes. We don't want to go through cycles. Yeah, we don't want to go through cycles. Yeah, that's important. We just don't want to go through cycles. So we need to make sure that we keep track of. So I have two vectors. We'll have one vector of booleans that just figures out whether or not we visited that point yet, and then another vector of the memoized function, which actually we just use the rooms as the memoized function, so we don't even need to do that either. Now that I'm thinking about it. Yeah, that's fine. No, no, we should memorize it. I take it back. We should memorize it. Yeah, because it gets kind of weird because we're using this to navigate as well as to write things to it. It'll get really confusing, I think, if we don't memorize properly. Yeah, I think we should memorize. Yeah. Okay. Anyway, all right. So let's do it this way. We want int and rows is going to be rooms.size, and columns rooms 0.size. Sanity check, or if we do sanity check if rooms are empty or rooms of 0 is empty, then we just return, and we're going to take we're going to say say RC to index. This is a nifty little routine, which is going to say int row, int column, return row times the number of columns plus the column, and vice versa, index to row to RC. We're going to take an index, return a row column tuple. Which is going to be the index the number of rows is going to be, I think, index modulo, or index divided by the number of rows is going to be the index divided by, I think, the size of the rows, number of columns, and then take the modulo of the number of columns, gives you the column. Is that right? I think so. Yeah, I think that's right. Okay. Number of columns is the size of the rows. So now we have those two routines. We're going to have a direction set. Directions is going to be pairs. Can do like, we'll just do auto. I think it works. I don't think it actually works that way. I think you have to do vector of, I actually want to do an array. Size 4 of tuples. We're going to say tuple int tuples. Be standard make tuple of, it's 4 different directions. It's going to be 0, -1. Actually, we're going to do north, east, south, west, right? So north is, it's going to be row column, right? So north is -1 row. East is, don't change the row, but increase the column. South is increase the row, but don't change the column. And east and west is going to be don't change the row, but do change the column to the left side. So we have our directions. This is going to be useful when we want to build our child sets. And now we want our depth first search. Now we want also our memoize vector of integers memo, and also vector of booleans. Both of these we want to be the size, we want the number of rows times the number of columns. Because every index, yeah, that's exactly what we want. And that'll start off at 0. And, or int max. Should be fine. And we just have visited. I actually think I'm doing this wrong. Initially false. How do we know that we wrote something to the column, the memoized column? Is it, it's not int max? I guess we just use visited. I guess we do that. I don't know. I'm actually not sure. Maybe unordered set is what we want. But anyway, we'll try to do it this way first, see what happens. So now we have auto F always, and now the context. Now we want int row, int column, and then we'll have an index, which is, you know, index to RC or RC index. Oh, we have another one too, which is inbounds of RC. That's a simple one. That's literally R is greater than equal to 0, and C is greater than equal to 0, and R is less than number of rows, and C is less than the number of columns. So inbounds, we want that too. You're going to say base case if visited of index, then return memo of index, memoized. Base case. Should be a couple base cases. Well, a simple one is if, oh, that's the other one too, inbounds, and there's actually one more, which is and rooms of row column, it's not equal to -1, right? That's a wall or an obstacle. So there's base cases we have. If not in bounds of RC, return -1, or return int max. If rooms of RC equals 0, return 0. Right? That's if you reach a gate, 0. If you're not in bounds, then you're int max. That really should be it, I think. And you memorize if you've already visited this position, then you have this, right? You memorize this index, and you're going to say for, really should be delta in, so it should be the children's set we're going to loop through. So for delta in directions, and really we could even do really something like this. Const auto d row d column. What we want to do is basically loop over all the children, which is all the different directions. So, which is fine. We could just loop over all of them. So, what we want is this int ret equals do int max. We'll start with, and then return ret and memoize index on ret. And we want to say each direction. We want to call, we're going to say ret equals standard min of ret, and I don't know. Yeah, we'll do it this way. Ret plus 1, so ret plus equals 1, and then return it. So we do standard minimum of each direction. So int new row, and it's going to be row plus dr. New column, it's going to be column plus dc. Standard minimum of ret, and f of new row and new column, and f. And we're going to, if visited, return visited equals true. We now visited this index, and if we say, yeah, return immediately if we visited it already. Whatever's there. Don't yeah, we go going backwards, so we don't really go backwards. It doesn't really do anything. We return whatever's memoized there, which if we haven't discovered anything yet, then there's nothing. And there's nothing. So loop over the children's set, curse on each. Increment whatever we get there, we increment by 1. Set that to memoize, return it, and then we DFS on obviously DFS we want to give that, but we can start with You have to be careful because, well, we're just overwrite whatever's on the. You have to be really careful about the. We can't even go through these inbounds. We have to do inbounds of new R, new C. Then we can update ret to those things. Yeah. Try to look at things that aren't inbounds. Okay, and now we can say, we'd start from something that's not a, find a starting point. Now here's the thing. Actually, this is really awkward. Brother, this is an awkward question. There could actually be... there could be... multiple connected components to this. You actually want to do it this way. Execute from every possible starting position. Sure, nothing's missed. You actually want to do it this way. As long as it's not equal to a gate, and it's not equal to a gate, it's not equal to a wall, an obstacle. You want to call DFS of RC DFS. Alright, being memoized, it should be excuse me, should be immediate if you've already called it. So this shouldn't actually cost very much extra. Yeah. We really want I haven't set the memo. Yeah, we'll do that. If you're not inbounds, then we don't really care. Okay, and now we just update. According to the DFS results. Alright, what happens if we do this? What do we get? Yeah, that's a fair point. Ret equals int max. Otherwise, ret plus equals 1. You make it idempotent if you're equal to the maximum already, then something like this. Wrong. Okay, expected. Output expected. Expected to be able to reach these different spots, huh? Oh, no kidding. So these were wrong. Ugh. All right. Wondering if we don't memoize, do we get the right answer? Just curious. Sometimes that happens. No. I may have like made a mistake somewhere. Oh, it's a lot of code to write before testing it. It's close. What happened? What did I miss? These all seem right. These seem okay. I think these are okay. Could be a bunch of different things. Kind of got to go like think about why would we be running into issues. This is kind of unusual doing it this way. This like if you visit it or not. You may, no. I don't know. That's kind of an awkward thing. The reason why you just don't want to backtrack if you've already visited this spot. Excuse me. All right, so this is the same input, right? 0, right? Infinity, 0, and 1, -1, or -1, 0, infinity, 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 -1, infinity, -1, infinity, -1, and then 0, -1, infinity, infinity. Okay, and the output should be 3. 1, 2, 2, 1, 1, 2, 3, 4. Okay, we got 3, we got the 1, the 2, 2, 1, -1 we got. 1, -1, we didn't get the 2, this one we missed. And then also -1 we got. 0, -1. These 3 we got as negative infinity. Now, why is that? I must have made a mistake somewhere here. Rows, columns, room is not 0, and it's -1, and call this on those things. And then write these also. So well, I had these different directions. So if you call DFS this way, and then this way, and then here, 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 and oh, that might be why. Oh, I see. Okay. Oh, yeah, that is why. Okay, that's very awkward. Right. Because you could visit a spot and not get anywhere, I guess. So we were trying to get this node, we visited here, and we didn't revisit here, and we didn't really get anywhere. The problem, I think between each call, we want to renew the visited set to, that's very awkward. Oh, I see. Okay. Yeah, so there is kind of a problem here, how we're handling this with things being visited or not, because you could have unconnected parts. Yeah, that's really awkward. Right. How do we do this properly? Actually, oh, this is very awkward. Huh. Interesting. Right. Very awkward indeed. I really gotta think about this for a minute or two. Brother, this is definitely awkward. The problem that I'm running into is we try these different paths, right? We get from nowhere. We're here. We try this path, and this path, and this path. This one immediately stops. This one we already visited. This one we have success. However, this one, there's no gate this way. And so all of these nodes actually end up with no gate, because we already visited this in this iteration. We already visited this spot. So you do have something of a problem where you don't want to backtrack. You don't want to revisit, I guess, the nodes that you backtracked on, but once you... Yeah, that's kind of awkward, huh? That's really awkward. Oh. This is very awkward. This is very awkward. Interesting. Yeah. You run into some problems doing this. I'll lay down for a minute. I think I ran into a problem that I don't see an obvious, easy or simple answer to. Uh-oh. Uh-oh. This, I guess, desire to backtrack is the problem we're running into here. This is a good question. We'll just put it that way. This is definitely a very good question. There is a problem, though. What you can actually do with a question like this is take a different approach. I think the depth first search approach has got some problems, we'll just say. At first, it seems pretty good, but when you think about it some more, it actually seems to kind of have a lot of problems. I think a better approach would actually be a breadth first search, breadth first search, where you actually radiate out from the gates. So find all the gates and initialize your. You do a level order traversal from each gate, and you would say, okay, this first level, all of these nodes are going to get, all of these children are going to get a 1, right? The gates are obviously 0, all these children are going to get a 1. And then all of those, the next children are going to get a 2. And then so on and so forth until every node is visited. Not until every node is visited, but until everything in the queue is visited, right? Like, so you put a bunch of children in, and they're either, they've got to be inbounds to be a child, and also to be, and also not visited yet. And if you do it that way, then you're sort of radiating out from all of the gates, and you should not run into the same problem that we just ran into. Now, there is a tricky thing here where you shouldn't ever need to resolve conflicts either, because you're running a level order traversal. Any node that you visited, the first time you visit it, that's going to be the best number it can get, the smallest number it can get. So you shouldn't actually have to resolve any conflicts. And you can do the same algorithm that I was just doing, the same idea that I was just doing here, where you have a visited set. You just make sure you don't revisit any of those children. And yeah, I think a level order traversal is what you want. That's probably better. Breadth first search. I don't actually know how I would reconcile the problem that I have here with the depth first search. It seems really hard to do. And similarly, with the level order traversal, you could write this directly to the rooms too. You don't really need to memoize anything. And for the cases that you don't reach, certain nodes that are not connected, you just leave them. Excuse me. You don't need to touch them because of you don't need to touch them because you're radiating out from the gates. So you just run one routine to grab all of the gates, put them in the queue, and then run your level order traversal. It's basically a breadth first search, multiple sort of sided breadth first search. Yeah, I like that. I like that a lot better. That seems to be a much more effective approach to this problem. I think I'm going to code this up and then just kind of lay down for a while. I'm getting a little bit, I guess a little worn out, a little tired. Excuse me. I feel kind of silly not recognizing this question for what it is, though. I've seen variations of this. I don't know. Whenever I see any kind of like graph-related question, I'm like, oh, depth first search. just do that. It's like, no, don't. That's maybe not be the best way to do it. Don't do that. You don't necessarily want to do that. Now, a really hard a harder question would be, how about, here, this question it's a little bit easier because all of the nodes, like all of the traversals, I guess, that you do, the values have a, what do you call that? Each node, the weight on each node is equal, right? Like in other words, if you went from, gate A to gate B and there's 5 spaces between them, every space costs you 1 to get from one gate to the other. Something like that. I guess I guess how the weighting on each section, how much it sort of costs you to move through it. You can actually, if you were to modify that, this question would be a lot harder because of the how that changes the graph and how that changes things. I don't know if radiating out anymore is the best approach, or you may need to start thinking about how you could resolve conflicts, something like that. I'm not entirely sure. Not entirely sure. Yeah, level order traversal doesn't really make sense anymore. I don't know now. Excuse me. That's a very good question. Well, the brute force way would be to sort of execute this on each gate individually, and just update. If you have a better number, you just update all the ones that you sort of move over. You update it with the better one, and you just do a breadth first search from every gate. You can do it this way too now. However, I think it's a lot more efficient to do a level order traversal from all the gates simultaneously. But yeah, if you have a small number of gates, then you can still do a breadth first search from each gate. I wonder. Yeah, I do wonder if there's a more efficient way to handle the handle this question if you have different weights on the spaces. So I'm kind of dozing off a little bit. Let me code this up, and then get on, and then I probably end stream after that. I kind of want to. I don't know. I kind of want to rest my eyes. I'm about to have a meeting with some church members in maybe half an hour or so. And I'm sorry. Yeah, in a short period of time, I'm going to meet up with some church members and have sort of group study, group worship, and yeah, and I kind of want to rest for like a short period of time before we do that. That's like, oh, that's pretty soon actually. It's like 40 minutes from now. Is that right? I don't know if I have enough time to do all this. I do want to get some time to rest first. All right, let's do that. Let's do that. Yeah. So level order traversal is what we want to do. Excuse me. Which is going to look quite different. So int is going to be level number. Start off at 0. We're going to have a queue of ints, call it queue. Could actually use tuples of rows and columns. Yeah, that's fine. And then we're going to say, for, it's going to do this thing. Initialize queue with gate positions. Okay. Then we want to have a while loop. Actually do new level. All right, increment the level number. I guess the first level number will be a 1. I'm going to say, well, queue is not empty. Const auto rc equals q.front, q.pop. Let's go through the children. So we say if visited of index, and just continue. Otherwise, we're going to set visited of index true. We're going to set rooms of RC equal to level number. We're going to go through each direction. Say this is inbounds. Then we're going to queue that up. It's not really push back, it's just push. Make the tuple of this new R, new C. So we update this visited to true. Inbounds includes whether or not they're visited. And we haven't visited them yet, which is really we could just do RC to tuple to index again. So we haven't visited them yet. They're inbounds. We haven't visited them yet. We'll put those children in. We will update queue the new level, update the level number, and I think do it this way. I think this is it, really. I mean, I think it's that simple. How do we do here? Whoops. Yeah, how do we do here? How does this compile? Oh, it compiles, but we're wrong. Nice. Nice. Really? What do we get? Oh, we're very close. Looks like we're just off by 1 at each point. Why though? It's pretty good. Oh, it's probably because, yeah, the level number should be 0. Because that's, we start with, nice rooms. Alright, I guess we just go for it now. I don't know. I kind of want to just go for it. I don't know. I'm tempted to just go for it. Yeah, let's go for it. Oh, nice, got there. Sweet. Hey, so how many pieces here do we need? We don't need this memoize anymore. Visited, we need, making these tuples is interesting. We don't need, we did use visited quite a bit. Inbounds is important. Index to RC, really didn't use that very much. RC to index, index to RC. Technically, you could make this visited set just, you know, what do they call it, a vector of vectors. Tempted to do that. Obviously pushing the indices here for the tuple is a little bit, but I mean you end up converting them back and forth between these different things anyway, so you know you kind of back and forth with this. But I don't think we really did index to RC at all. Let's see. Yeah, I think some pieces we really didn't use. Interesting. also not entirely sure if we needed this, you know? Because you could check the level number against the current level number. Like you could check rooms. You could check this value instead of checking if they've been visited or not. I don't think you actually need to have this visited vector here. Yeah, you can do it that way. Let's actually remove the visited set. Let's do rooms of new R, new C. It's not equal to int max. Let's try removing that, see like where that goes. We might want to run this check. No, that's wrong. I don't know. It's not equal to. We want to make sure it's in bounds. Interesting. Do you need that at all? Wrong. Ended up not setting things what they're supposed to be. Oh, I think it's. Maybe that's why. Huh. Some of these are right, some of these are wrong. Uh-oh. Uh-oh. Hold on. Trying to use this as instead of the visited set. So this is definitely visited, right? If this is, or not visited rather, it's definitely not visited. However, normally we would say if you were not visited, or if you were visited, then you would continue. And that's totally wrong. It's also confusing. Why does this not work? Wait, what? Oh. Because the initial rooms are 0. Aha. Aha. Gotcha. Oh. How about that? Nope. No. I don't know. I did it wrong. Did this very wrong. We don't skip if it's equal to this guy, or it's equal to this guy. We say no. We don't skip. Obviously, the visited set makes things a lot more clear. All right, there we go. That's right. This is, by the way, not equal to and not equal to, which is very confusing, I realize. So I gotta get off here. All right, how do we do? Okay, still correct. Hey, it's faster. Faster is still correct. Yeah, so you do want to not equal to 0 and not equal to int max. If you're not 0 and you're not int max, then you want to continue. That means you've already visited this spot. Yeah, so you don't touch it again. Right, 0, we don't know if they're visited or not. But in theory, you're never going to reach the 0 because you're radiating out from the 0 anyway. Interesting. So you don't need the visited array, and you don't really need the RC to index. Now you could probably modify the this queue to use an index. Although, I mean, inbounds is, yeah, it's probably better to just use. Let's not even bother with these indices. Is that even used anywhere? I don't think so. I don't think that index is used anywhere. Yeah, so we can do that too. I don't need that anymore. Simple inbounds, directions, level order traversal. Spent kind of a lot of time on this, but this was enjoyable. This is interesting. All right, I'm gonna go. Thank you all for watching, hanging out, saying hello. Do appreciate it tonight. Not necessarily this particular problem, but had somebody come by and say hi, so I appreciate that. Yeah, I spent an hour on this. Spent a lot of time on this one. Let me go. Yeah, thank you again for watching. I appreciate it. I'll talk to you soon. Have a nice day. Maybe the discussion would be good to look at this, but I'm not going to. I'm just going to move on. I definitely learned a lot, though, reading the discussions. Maybe there's something quick that I can read. I kind of want, like I said, I kind of want to like take a break for a minute. 6 lines, OMN, BFS, Python, BMS, BFS. Wow, mine is not 6 lines. Mine is many, many lines. I mean, I prefer it this way, though. It's like pretty clear what's going on. But let's find out then. Also, a lot of the stuff I've noticed that Mr. Bachman puts together, right, they're kind of not the most legible. They're like kind of deliberately terse. I mean, it's good, but it's a little bit, you know, it's like maybe more than is necessary, something like that. I don't really know what's going on here, but it's a breadth for search. I mentally prepare myself for ego gut punch before I click this solution. As good as it gets. It's too funny. Learning your code for a long time. Concise and efficient. DFS. Excuse me. I don't know, man. I kind of got hung up on the DFS. I don't know what the DFS would look like. I get BFS, but DFS I'm not so sure. Oh, wow. No kidding. Interesting. Quicker than BFS, really? Number of islands. So you DFS from IIJJ. Interesting. This is really concise. That's interesting, yeah. Check the distance. Yeah, so basically this is a depth first search from each individual position. Which is fine, I guess. Which is interesting. This is what you would do if the weighted graph, if there was a weighted graph instead of each edge between each node, it sort of has the same weight. So the breadth first search, level order breadth first search works nicely. But I like this. This is pretty good. I'll have to keep this in mind in the future. You just depth first search from each source and overwrite the values as you come across them. It's definitely more expensive to do it this way, as I said. This is basically like a breadth first search from every node as well. It's the same kind of thing. This is slightly less efficient, by the way. This is slightly less efficient. Actually, quite a bit less efficient. Someone was saying that this is faster, but one of the depth first search, but it's actually not. Quicker than BFS? No, it's not. No. Yeah. What he's just saying is, I think, correct. Anyway, all right, let me go. Pretty neat. So thank you all for watching again. I'm gonna go. I think I said that a few times. Have a good rest of your day. Thanks for coming by, and have a good night. Take care.